Hey, Miss Marion here. Let's go ahead and do Unit 5, Lesson 11. Turn back to page 191. Let's read the I can statements. I can collect data about a function and represent it as a graph, and I can describe the graph as a function in words. Go ahead and give yourself a sentence, how you feel about those, and then also a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it, but then 4, I can teach it to my friend. All right, let's go ahead and turn to page 95. You see all 4 different objects, and this picture is not in your workbook, but let's go ahead and do that. So which figure doesn't belong? So blank doesn't belong because blank, so you have to kind of give your reasons for. Go ahead and write down your reasons. So pause and write it down and then come back to me. All right, some of the things that you could say is that figure A doesn't belong because it only has 2 surfaces, or it only has 1 base. Figure B doesn't belong. B has no edges. It's a circular kind of stuff. Figure B doesn't belong because it would always roll around. It doesn't have a flat surface. Figure C doesn't belong because it has a top and a bottom with a circle. Figure D doesn't belong because it has flat surfaces all the way through. So up to you on which one doesn't belong. It's more getting our brains thinking about different type of objects for today. All right, let's go ahead and turn to page 95 through 96. We'll be using an applet to investigate the height of water in a cylinder as a function of time, volume. And so what I need you to do, we will be filling in this table here with the information. So what I need you to do is go ahead and open another web browser, so Chrome or anything like that. Type in this website, this URL, without the www. Just type it in exactly how it is, and it will bring up an applet. It will actually have a cylinder on there, and you can actually fill up the cylinder and see how much it is as far as different pieces of information. Don't change the radius, just go ahead and fill it up, find the height. So our diameter right now is 5 centimeters is what we want. And go ahead and fill in, put water in it. So kind of fill and press pause, fill button. Fill in the water and then see what the volume will be at the different types of heights. And so go ahead and do that. So you'll need to pause this. Go ahead and do that. Fill in your table and then come back to me. All right, so I went ahead and worked with that applet, and I decided to go ahead and fill it in as far as the height of kind of going up by 0.5 centimeters. And this is the information that is given to us as far as the volume for that cylinder. You did not have to have the same information, but if you want to, you can go ahead and copy this down. I will be using this information in a second because we're going to be asked to go ahead and graph this. But again, you did not have to have the same information as me. So on page 96, if you look at number 3, we're also going to go ahead and make a graph with the information that we have. If you scroll down on the applet, you can actually put in the information. It will make the graph for you, or you can make your own graph on the page 96. And so make sure that we're doing that the height of the water in the cylinder is a function of the water of the volume. So go ahead and do that. However, you can use the applet, or you can go ahead and use make your own graph itself. But make sure you label your axes with all the information that's on there. So go ahead and pause. Go and do that pause and then come back to me. All right, so this is the graph that I went ahead and made. Notice how I used the applet that was actually on, if you scroll down, you can go ahead and put in your points in the table, and then go ahead, it will go ahead and make it itself. If you notice, as far as the applet itself, this first part is my volume, and the second part is my height. Also notice on the graph itself, the volume's down here, because it wanted as the height is a function of the volume. So my height is here, and my volume is here. And this is the type of graph that I went ahead and made. So on number 4, what we're going to do is we're going to choose a point and explain what it means in the context of the situation. So pick a point and explain it as far as what it actually goes ahead and means. So go ahead and pause that and then come back to me. So I'm going to go ahead and I'm going to pick this point here. That point is 39, 2. I'm going to go ahead and label it. So the first part, the 39, is the volume. So really, I can actually, let's write that a little bit different. We're going to say our volume equals, and it's going to be 39, and let's go ahead and put the measurements with it, milliliters. And then the 2 is our height. We're going to say the height equals 2 centimeters. So what does this actually mean? At the height of 2 centimeters, my volume is going to be 39 milliliters. So this is what it means as far as the story, or what is actually going out along with it. So let's go ahead and just kind of look at some stuff here. What do we notice is the shape of my graph. My graph is actually kind of going up. It's kind of linear. It's not curved or anything. What is our independent variable? So our independent variable actually is our volume. Our volume's down here. This is our independent. And then remember, our y-axis is our dependent. How does this graph differ from what you predicted the shape would be? So some of us might have thought like the graph might have been curved instead of a straight line. And so also notice how we have the volume down on the bottom and the height going on our y-axis. Sometimes we actually see this flipped as far as the height actually comes first and then our volume. So we can actually write it both ways. So we can say, is height a function of volume and is volume a function of height? We can, because we still get one input for every one output. So that's what a function is. An output is a function of an input, 1 to 1. Do we actually have that? Yeah, we do. So can we write it, can we say it both ways? We can. And so this is kind of what we're kind of looking at for today. So here is kind of a height and volume kind of information. Here's a graph with different cylinders with different diameters. One cylinder has a radius of 1, another one has a radius of 2, and the third one is a radius of 3. How did the slope of each of the graph change as the radius increased? So go ahead and think about that for a second. How did the slope of each graph change as the radius increased? And if we look at it, as the radius is larger, the slope is less steep. So as the radius is larger, the slope is less steep because, and this has to do with the volume being on the bottom and the height being on the y. So this one is actually a radius of 1. Here is the radius of 2. And then the last one is the radius of 3. So so our radius is larger, the slope gets steeper. This is because of the cylinder with a large base, the same volume of water, it will not fill as high up to the sides as a cylinder. So all of the volume that we're working with, it's going to kind of change. We're still doing the same volume, but it's going to change as far as how high it's going to be on that cylinder when we get that radius larger and larger and larger. So if we turn to page 96 to 97, we're going to start with page 96, and we're looking at number 1. The graph shows the height versus volume of an unknown cylinder. What shape could this container have? And explain how you know and draw the possible container. So go ahead, you're going to pause and answer this question, and then come back to me, okay? All right, so let's kind of look at it. So notice how, again, the volume's down on the bottom. The height is in cylinder, is here. So it's kind of getting bigger, and then it goes ahead and changes this way. So what could this actually be? This shape is 2 different cylinders stacked on top of each other, with the upper cylinder having a greater radius. So let's go ahead and let's kind of draw that. So we have a cylinder down on the bottom, okay? And then we have a bigger cylinder, the radius is bigger, up on the top. So notice how it kind of, down here, it goes ahead and it has the same, as the volume gets bigger, the height of it gets bigger, and then it kind of changes here. So we have a smaller radius and then a larger radius, and then this would actually be our picture. Let's look at number 2. The graph shows the height versus the volume function of a different unknown cylinder. What shape could this container have, and then how do you know? And then eventually you're going to answer, how are the 2 cylinders containers similar? how are they different? And that's looking at the graph number 1 and then also graph number 2. So let's go ahead and answer this question. So actually, let's just answer number 2. What kind of graph would this be? And then we can kind of go from there. So pause, answer that question, and then come back to me. All right, let's look at it. So it has a cylinder. Notice how has the same. It changes, and then it changes again. So we can actually have the bottom as one cylinder. Then we have another cylinder, and then we have another cylinder itself. So we have actually 3 cylinders stacked upon each other. The bottom would be the tallest. So we're going to have the tallest here, right? And that's the first part. Then we have this second part, and the middle cylinder would be shorter, but have the same radius as the bottom. So we're going to have shorter, but the same radius. Then we have our last one, which is here. And this one, the top cylinder is the shortest, but have the largest radius. So it's going to be a little bit bigger, and it's going to be shorter than the rest. Okay, so notice how we have 3 cylinders stacked upon it. So let's go ahead and let's answer the question, how are the 2 containers similar? How are they different? So both containers are made up of cylinders stacked on top of each other. So again, we're actually answering this question between number 1 and number 2. So both have different containers stacked on top of each other, but the first one only has 2 and the second one has 3. So they're kind of the same, but different at the same time. All right, let's look at, are you ready for more? So this graph shows the height versus the volume function of an unknown container. What shape could this container have, and then how do you know? So go ahead and pause and answer this question, and then come back to me. So notice how this graph is actually, it's curved, okay? So this is not going to be a cylinder. So I don't know if you kind of came up with it, but it's actually a cone. And the cone is actually kind of sitting on its like open end. So notice how it goes as far as the volume is going to be really, really large at first, right? And as you keep on going, it's going to get smaller, 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 smaller. So that's what this graph is actually is. It's a cone, but sitting on its open end. So today we were talking about filling in different type of shapes and different type of cylinders with water, and we can actually see how the dimensions are different. Remember how if we have different radiuses, it kind of changes our volume. So we're just kind of looking at all of those together and seeing how kind of how some things can be the same and also be different. We were looking at graphs and how those actually change and also. So let's go ahead and go back to page 191. Read the I can statement. I can collect data about a function and represent it as a graph. That was the first part when we were looking at the different volume and different heights. And then I can describe a graph of a function. And that was the last 2 questions. So go ahead and write yourself a sentence about how you feel about today's lesson. And then go ahead and give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. Make sure you do the practice problems. Make sure you get into Canvas and do those practice problems that are due tonight. Have a good day. Thanks. Bye.